Since we view inventory as waste, then transportation can be viewed as a way of accumulating inventory on the move, which is, of course, something we want to eliminate also. If we can tie all production processes with an invisible conveyor, producing one piece at a time and transporting one piece at a time, we would have the ideal flow production system. Here, transportation is represented by valves connecting separate pools of inventory in the manufacturing process. If pressure builds up for too long before the valve is opened, the discharge of inventory is similar to a discharge of water from a dam. From this analogy, it should be obvious that transferring materials in large batch sizes creates a glut of material flowing in a disorderly fashion. Because of this, new roles for transportation function may be developed in order to pursue the following objectives. More frequent deliveries. More frequent feedback of information between the processes. For example, quality problems, work priorities, and the like. No storage between the processes. And reduced transportation costs. Even though some of these objectives may seem conflicting, we can still address them by using creative thinking. For example, transferring Kanban cards may convey accurate production information to the upstream process. Mixed loading of trucks and multi-plant scheduling may allow frequent small lot deliveries. Returnable containers may reduce material handling costs. Furthermore, we may be able to develop a one-touch handling method and deliver the material to point of use. Let's compare some conventional and innovative approaches to transportation with this illustration. First, the conventional approach. This represents large lot infrequent transportation. The results are slow feedback of information, accumulation of inventory, and additional problem impacting quality and increased expediting work. Next, this shows a mixed loading arrangement. Parts are delivered more frequently, inventory levels are lower, and the entire situation is much more streamlined.
The transportation loop is similar to a bread truck route in that the truck begins empty from our plant here and runs a fixed loop at a fixed time, stopping at numerous vendors and returning to plant full. The loops obviously vary in length of time, but the truck is on loop, the frequency of pickups, and also the number of trucks that are on the route at any one time. The result was a saving of 1/3 to 1/4 of the previous transportation cost.
In incorporated Kanban theory here at Apple, we've eliminated a lot of our inventory. We've downsized our inventory considerably. Also, we have now utilized a truck instead of a rack, which is warehousing material in-house. We now warehouse it in a trailer on the lot, and it's utilized as we need. We generally have 2 trailers full of material of each product sitting on the lot at any one time. One will be backed up to a door, the other sitting there in case this one gets emptied. Upon emptying this material of one at the door, we then return it back to the vendor, pull up the other trailer, the vendor in turn fills up and sends it back, which means we always have a continuous loop of 2 trailers on the lot at all times. This has really helped in a positive manner. It eliminated a lot of our inventory in the racks and warehouse. It's given us more space, more flexibility, and has really helped in a lot of the teamwork. It's a lot easier to deal with it out of a trailer than it is to pull it out of racks.
What we're doing here at Apple Fremont is trying to utilize our packaging as much as possible so that we can bring the cost of the unit down per part. And we've recently brought the plant up on a reusable packaging program. And what I'd like to do is show you how we utilize the packaging in such a manner that we have no waste and we recycle packaging through each of our vendors. What we have here is a Mac 2 bottom. And what you see here is a piece of sheet metal in a piece of plastic. The packing starts with the sheet metal supplier, and the sheet metal supplier stamps out this piece of sheet metal here. They will put this sheet metal in this box with partitions. You'll see that 4 top are in this box. Sheet metal supplier puts 4 of the sheet metal parts in the box, ships it to our plastic supplier, molds this injection molded plastic. They heat stage sheet metal into plastic, do prep work such as add printing, logo, and put it back in the same box with the same partitions, ship it to Apple. Comes here to Apple Fremont, remove parts on the line, send the packaging back to E-Trash, people in E-Trash knock it down, send it back to the sheet metal supplier here. Thus, the packaging hits 3 different suppliers. What you see here is a design that makes easy utilization for each supplier that hits. We have an HSC style carton with no top flaps. Thus, a person that's working with the carton has no top flaps to get in the way of the utilization. You'll also notice it has handholds for easy access to lift and carry. What we do, this is a quarter pallet size. We bring 4 boxes in per layer, and there's a layer lid that goes over each layer. One person removes that layer, and we have 4 totes exposed. This packaging actually goes right to the line, and there's no trash whatsoever. The parts are exposed, and nobody double handles parts.
At Toyota Auto of California, parts are delivered to the line, and the operator informs the trucker by electric signal. This signal turns on board light on and informs the trucker what parts need to be delivered and where.
So this is basically an extension of flow production, a way to ensure that there will be very little inventory accumulated in the pipeline.
Yes, the key here, just like anywhere else, is to look at the overall picture rather than simply focusing one's own efficiency.
Multiple delivery is an example, isn't it?
Yes, it may cost more to do multiple deliveries if we look only at transportation cost. But if we look at the total cost, including reduction of inventory, space, material handling, and so on, it may make a lot of sense.
But to make this happen, we need to work together closely, right?
Yes, a good transportation network requires close communication too. So the closer the location, the better the linkage. Just as we talked about small and mixed production reducing the lead time, small and mixed transportation are also necessary to streamline the factory operations.